Hello, my name is Anna and welcome to this presentation on how does language experience shape sentence expectations in the frame of cloze norms. In studies of language prediction, we usually test how are people able to anticipate the end of a sentence before it is presented to them. However, as you can imagine, there are so many different sentences that we could use in this type of experiments. So we need a way to make sure that they're predictable enough to elicit prediction in the participants that we test. For that reason, before we run our main experiments where we test language prediction, we run a previous cloze test where we test whether the sentences are constraining enough. So in those cloze tests, we show incomplete sentences to some participants and we ask them to think of the most likely continuation and to write it down. We repeat this process with many different participants, and at the end, the level of answer consistency across all of them tells us about how constraining the sentence is and how predictable it is. Now, although we do need to test different participants in the cloze test and in the main experiment, because otherwise we would be including a huge confounding variable, we do need to make sure that they come from a similar population to be able to generalize the answers from the cloze test to the main experiment. Now, the question is, what do they have to be similar in? And in the next 5 or 6 minutes, more or less, I will convince you that language experience is one of those variables. So we run a cloze test through Prolific with 330 sentences in French with different language groups. So first we had a group of dominant speakers of French, then another group of dominant speakers of Spanish who were fluent but not dominant in French, and similarly another group of dominant speakers of English who were again fluent but not dominant in French. To get a quantifiable measure of this answer consistency across participants, we obtained response entropy. Now, response entropy is minimum and it's actually 0 when all the participants give the same answer. In this case, the sentence is considered highly constraining and highly predictable to whatever the participants answered. In this case, umbrella. If each of the participants gives a different answer, then response entropy would take its maximum value, which is linked to the number of participants. In this case, it would be 12 participants, therefore 3.58. And it would mean that the sentence is super low constraining and super predictable because each participant gave a different answer. Then this response entropy gave us a quantifiable measure of sentence constraint for each of the sentences and each of the groups. And to see how much the groups aligned or differed in this sentence constraint, we obtained Spearman correlation. We also went a step further, and to be able to further interpret this observed correlation, we compared it against some benchmarks that were tailored to our data. So first, we obtained some shuffled data pairs from our original dataset. And from that simulated dataset, we obtained the Spearman correlation. And when we repeated this process, which is called permutation testing 10,000 times, we obtained a distribution of no agreement. Because again, it comes from a simulated dataset of shuffled data pairs, which shouldn't be aligned. Then we also took each of the groups, we split them in half, and we treated them as if they were different. So we obtained the response entropy scores for each of the sentences in each of those two subgroups. Then we calculated the Spearman correlation between those two datasets. And again, we repeated this process 10,000 times. With this, we obtained a distribution of maximum agreement. And when we compare where is the observed correlation against those two distributions, we are able to further interpret it and to see how meaningful it is. So when we compared the response entropy scores of the French dominant group versus the Spanish dominant group, we saw that their observed correlation was not null, but it was also not maximum, as you can see in this graph. And a similar case happened when we compared the group of dominant speakers of French versus the group of dominant speakers of English. However, when we compared the two non-dominant speaker groups, we saw that their observed correlation was actually overlapping the distribution of maximum agreement. And with this, we can conclude that the response entropy scores were as similar as possible between the groups that had similar language dominance, and that those scores were actually not that similar when we compared groups of different language dominance. We also did an extra comparison between a group of dominant speakers of French and a group of dominant speakers of Spanish answering to the same translated sentences in each respective language. And in this case, we found that their observed correlation was not null, but it was again not maximum. So with this, we can conclude that on top of the groups having to be of similar language dominance, they also need to have the same language. So with these results, we can conclude that the groups tested in the cloze test and in the main experiment need to have a similar language experience, defined as similar language and similar language dominance. We know this because whenever we compared the response entropy scores of groups that had different language or different language dominance, we saw some differences. And again, this also means that monolingual or native speaker norms are probably not the most reliable reference points for when it comes to bilingual processing. So with all this information, at least we can say that in language prediction studies, we need to obtain norms from a population that is as close as possible and that is tailored to the one tested in the main experiment. Thank you.